Hi, so I'm Rachel Lako, and I'm a junior studying biology at the College of William & Mary. I have 4 other teammates who couldn't be here today, and they are Michelle Chang, who's a public health and biology double major, Chinonso Yuzawe, who is an environmental studies major, Erin Butler, who is a sociology, anthropology, and math majors, and Rigo Garcia Vonsaki, who's a natural resources management major.
Hi everyone, my name is Lane Graham. I am a PhD student at the University of Central Florida. I'm studying GIS and sociology under Dr. Timothy Hawthorne. And this work is a product of a 3-year National Science Foundation Research Experience for Undergraduates program with a field site in Belize. Our core interdisciplinary team consists of principal investigator Dr. Timothy Hawthorne, co-PI Dr. Christy Pasagi, program evaluator Dr. Olga Jarrett, myself the research coordinator, Christine Munaseri, also research coordinator. And our program has 2 distinct research tracks: flooding disaster management, which you may have heard about yesterday in room B from our own Kate Brandt. And today we'll be discussing the results from our marine debris research track. Our study area is Hopkins Village, a small coastal community in Belize, Central America. Hopkins is traditionally a Griffna community, which is a mixture of West African and indigenous cultures. The village is home to about 1,200 permanent residents and has a 3-mile stretch of coastline. Many tourists visit Hopkins for its beaches and Griffna culture. Traditionally, fishing has been the primary local economy, but it's quickly shifting to tourism. Residents have identified marine debris as a prevalent problem on the coast of Hopkins. Marine debris is a problem year-round, and it contains a variety of items that can be threatening to people's health, such as syringes, cut coconuts that can harbor water that are vectors for mosquitoes, and other natural debris, such as this man-of-war that is washed up on shore, pictured above. In addition to aesthetic and safety concerns, marine debris can negatively impact tourism, which plays a significant role in the economy of Hopkins. So why are we doing this? What is our goal? Our mission is simple. It's to provide international experiences for students in community geography and GIS that connect research to real-world problem solving, and that is inclusive of knowledge production from local stakeholders. When traditional data collection methods are coupled with community-based participatory GIS approaches, it makes for more inclusive, informed, and successful research projects. So our model consists of 8 undergraduates that are competitively selected from diverse disciplines across the country. And they're selected annually, so we have a different set of undergraduate students every year. These student researchers work collaboratively on one of 2 research tracks: marine debris or flooding and disaster management. Last year, each track had an additional team member that we were very excited about: a University of Belize intern. This work is community-based and collaborative, and it aims to include the community at every stage of the research process. Our research this summer was broken up into 3 distinct phases. Phase 1 was held in Orlando. Students and staff met at the University of Central Florida to get to know one another and to begin the research process. We outlined initial research questions, we initiated the literature review, reflected on last year's work, and students completed 10 ArcGIS training modules. The second phase was spent in Hopkins Village. The first few weeks were spent walking around the village, getting to know the residents, talking to residents about how marine debris relates to their community. We held planning meetings with the village council and local partners and updated last year's MOU. We worked with collaborators and community partners to finalize our research questions, to build our geodatabases, and to test them, collecting our quantitative data and qualitative data with the community. Before leaving Hopkins, we held an event to present our preliminary results. The final phase of the program was spent in Orlando, using ArcMap to analyze the data and ArcGIS to publish it. It's now available online for our collaborators and Belizean partners to access. This summer, we worked towards building quality data sets that will soon be freely available and open for everyone to use, contribute to. Belize is data scarce, and what has been collected is often protected. Our data are products of participatory approaches that engage communities at every phase of the process to build data that can be contributed to, verified, and used to document and manage real-world problems. There were 4 main components to building these data: the collection and processing of drone imagery. The satellite imagery is poor and outdated for our study area. Therefore, we used a DJI Phantom 4 quadcopter to map Hopkins and used Drone to Map to stitch thousands of images together to make an orthomosaic, which served as our base map. We fly the area every year to monitor the effects of natural disasters, climate change, and development. Local knowledge is the second component, and it's a main aspect of our work. Whether it's casual conversations or structured interviews with Hopkins residents, these qualitative data helped us to better understand marine debris, their impacts, and their effects on the community. The next phase is the quantitative data collection. We collected data on marine debris abundance and type along the 3-mile stretch of Hopkins coast, using a quadrat to quantify the debris. Finally, the citizen science component, we worked with community members during the entire process, from structuring our research questions to data collection. And we still have several community partners who continue to collect data on marine debris year-round.
So this summer we focused on 2 main research questions. The first was looking at the distribution, type, and abundance of marine debris along the 3-mile stretch of Hopkins coast. And then the second aspect was incorporating local knowledge. So we perception mapped with community members, and we asked them what areas they are emotionally attached to or they value highly, as well as which areas they perceive to have high amounts of debris. So to begin with, our beach survey data collection, we started at the lagoon in the north end of the village and walked all the way to the mangrove forest in the south, which is a 3-mile stretch of coast. Every 50 meters, we would take a sample, and then we utilized the Art Collector app which has offline capabilities, which enabled us to collect data even when we didn't have internet access. So during our beach survey, we collected 3 different types of data. The first was broad data about the characteristics of the sample site. So we collected information about the slope of the sample site, the level of erosion, whether the sample site was raked or not, and what kind of land development was in the adjacent area. So if there's a hotel behind the beach, or if there's a residence or a restaurant. As you can see in the lower picture, there were distinct strand lines on the beach, so different areas where debris would accumulate. And at each sample site, we would sample each of the strand lines. So in the picture on the screen, there's 2 strand lines. In some sample sites, there'd be 3 or there'd be 1. So the number of samples would vary depending on that. And then the other 2 types of data that we collected were the quadrat data, which enabled us to collect percentage cover. So as you'll see in the quadrat, there's lots of natural debris. And so we used the quadrat to count the squares to quantify how much seagrass and sargassum was found at each sample site. And then we also collected information on the type count of debris, so how many plastic bottles, coconuts, etc. we found in the quadrat. In the top picture, you'll see 2 of my teammates, Erin and Michelle, collecting data with community members and teaching them how to use the database that we created so that they could continue data collection once we left. This map shows our findings on the accumulation of natural debris along the coast. So each point represents a sample site, and there's about 100 sample sites along the entire stretch of the coast. The different colors indicate the different land development adjacent to that beach. So there's residence, recreation, hotel, etc. And then the different sizes of the dots represent the amount of debris found in that area. So the larger the dot, the higher the accumulation of natural debris. So if you'll look at the higher inset map, you'll see that the dots are bigger and that there's more of a mix of colors, which indicates mixed land use. And so this was in the northern part of the village, and there were higher accumulations of natural debris there. If you look at the lower inset map, this was taken of the southern portion of the village, and the dots are smaller, which indicates less accumulation of debris. Predominantly in the southern end of the village, there are resorts, and the resorts rake their beaches every day for the tourists, which is why you can expect less debris in that area. So this map is similar to the previous map, but instead of natural debris, it shows the abundance of plastic debris. And you can see that there's a similar pattern between the 2 maps of less accumulation of debris in the south end of the village, again where the resorts are. And then if you're looking up towards the northern portion of the village, there's higher accumulations of debris. So to sum up our beach findings, we found that there is a relationship between the type of land development and the accumulation of both plastic and natural debris, and that we found high accumulations of both of those types of debris in the northern portion of the village, which is the more residential and traditional part of the village, and that especially in front of the pier and the old school grounds, which are areas that we'll talk about with the perception mapping. We also recorded low accumulations of debris in front of the resorts, which are found at the northern and the southern tips of the village. So the second question that we looked at was incorporating local knowledge and recording community members' emotional attachment to different areas of the village, so which parts of the village are important to community members, and then also which areas do community members perceive to have lots of debris, because we're just coming in and we don't live in this village, so we want to know what the people who live there know and learn from their knowledge. So we interviewed 101 people while we were in Hopkins, and we collected demographic information, so that included people's age, their affiliation to Hopkins, so that's pictured in the graph below. So if they're a resident, if they're a tourist, if they're an expat, or the other section represents people who are from areas in Belize outside of Hopkins, so kind of surrounding communities who didn't identify as a resident. And then we also collected information about people's occupation and their time spent in Hopkins. The next component of our data collection was looking at more research pertinent questions. So we asked people how marine debris affects them on a daily basis, if it does, where they think the debris is coming from, as well as what sort of solutions they would like to see to the problem of marine debris in their village. And then the last component was the perception mapping. So we had tablets, and we would ask people to indicate on the tablet areas that they were emotionally attached to or that they found a high abundance of debris. And so we just had Art Collector open in an editing session, and they were able to tap points on the screen and indicate the areas that they would like to select. So these are the two questions that we asked while we were perception mapping. First, we asked if there were areas that were of particular value, and we also recorded people's response of why they valued that area. So like if it was a family area or if it was a place that they like to go to relax. And then we also had the coded values, which people chose from as well to indicate why they valued that area. And then the second question that we asked people was where they found high accumulations of debris in the village. And we also asked them to identify which types of debris they found most frequently there. And the choices are described below. So the results of our emotional attachment perception mapping, out of the 101 participants, there were 108 polygons drawn, and over 30 of these polygons indicated the pier area and 30 indicated the old school grounds, both of which are public areas that were named as important areas because of their cultural and recreational significance. So this map compiles all of the 108 polygons that I just talked about, and each polygon was assigned a value of 1 to 5, ranking its level of importance. So a polygon was assigned a value of 5 if it was highly important and 1 if it was not very important by the community member. So you can see that there's two hotspots that kind of show up indicated in the inset map on the right. And the northernmost hotspot is where the pier is, and you can see there's a hotspot a little further to the south, which is where the old school grounds are. This map combines the debris abundance data that we collected from the beach survey with the perception mapping data that we collected about debris abundance. And so you'll see that, again, as in the previous map, the areas that are darker and red indicate more people noting this area. And with these polygons, they were assigned a value of 1 for a presence value. So these were all stacked. And then the areas that are darker indicate more people believing that there's debris there. And you can see alignment between where we found debris in our beach survey with the larger blue dots, as well as where people indicated perceiving lots of debris. So you can kind of see that where people know where the debris is, and our data kind of corroborates that. So to recap, we found that the debris abundance is high along the northern coast of Hopkins, especially near the pier and the old school grounds. And this was through our quadrat and our surveying. And then we also found that there's a relationship between the type of land development and the abundance of plastic and natural debris in Hopkins. And then with our perception mapping, we found that the old school grounds and the pier are both highly valued by community members, and that's for recreational and cultural reasons. So by collecting both quantitative beach survey data and qualitative perception mapping data, we were able to look at human-environment interactions on a deeper level, and we were able to consider how marine debris especially pertains to the village of Hopkins and why it matters to the people there. And so we were able to look at where debris is found and where people believe debris to be found, and also how people utilize these areas.
So the bigger message of our work is the importance of local knowledge and participatory GIS. Working together, we are stronger, smarter, and more invested in the task at hand. Community-based research approaches help us to deepen our understanding of marine debris and to address the causes, types, and effects of marine debris in Hopkins and beyond. Our study was not without limitations. In our quantitative data collection, we were unable to access some of the locations along the 3-mile stretch of coast. These areas were either obstructed or inaccessible, and therefore our quadrat could not be placed at that location, and those spots were absent from our sample data. Another limitation was public participation. So while we did have some help in the data collection process from the community, we would love to engage more residents in this process. So we're going to be looking at how to recruit better in the future to make sure that we have community members out collecting data at various stages. Finally, we're only in Hopkins for 30 days. So that's a limited amount of time, and it only is representative of one season. So it'd be beneficial to work with our community partners to collect data on the seasons where we are not able to be there. So for future research, we are only in year 2 of 3. These longitudinal data will allow us to see trends of debris accumulation over time. And we're excited to continue to build upon our research from the previous years, to seek new analytical tools to increase participation by the community, and to see how the community has utilized the results of the last 2 years of our data collection to identify priority areas and work on solutions in the community to address the debris accumulation and type. So we'd like to thank all of those who made this experience possible. We'd like to start by thanking all the people who shared their stories, their lives, and their time, and thank all of you. Without the innovative products that Esri makes, this would not be possible. So if you'd like additional information about our work, please look at our website. It's citizensciencegis.org. Contact our PI, Dr. Timothy Hawthorne, at timothy.hawthorne@ucf.edu. Check out our social media pages, and please come to talk to us after this presentation. We'd be happy to take questions at this time.